Hello students. So finally we deal with the last topic of surface areas and volumes, where we talk about frustum of a cone. So what is a frustum of a cone? So here is a cone, and if the cone is actually cut such that you get this region, it's like you have a cone here and a portion is cut off, and you have a portion which resembles a glass. So here let us assume that R1 is the radius and here R2 is the smaller radius and h happens to be the height. Then the volume of the frustum of a cone is given by this expression, which is 1 by 3 pi h into R1 square plus R2 square plus R1 R2, and the curved surface area equals pi into R1 plus R2 into L. And what is L? L is given by square root of h square plus R1 minus R2 the whole square. And we also have the total surface area of the frustum of cone given by pi L into R1 plus R2 plus pi R1 square plus pi R2 square. So this is the total surface area. Of course the derivations are not there. So in the optional exercise we have two problems where we derive these two expressions, so we'll go through that in detail. So let's solve the problem. The problems are very easy. You just have to remember these expressions, mathematical expressions. So let's go through the first problem. So we are solving problems of exercise 4 given in your textbook. So exercise 4, I have the first problem. So drinking glass is in the shape of a frustum of a cone of height. So you have a frustum of a cone which is nothing but a drinking glass. So the height h equals 14 centimeters and we have two diameters, right? So the diameter of the two circular ends are 4 centimeter and here you have 2 centimeters. So these are the two diameters. So I need to find the capacity of the glass. So how do you find the capacity of the glass? So basically we have to find the volume, which is given by this expression. Now the given data is the diameter here. So the larger diameter is 4 and the smaller diameter is 2. So the radius R1 is 4 by 2, which is 2 centimeters, and the smaller radius is 2 by 2, which is 1 centimeter. So all the values are given. So therefore we have the volume equal to 1 by 3 pi into h is 14, into, so I have R1 square which is 2 square which is 4, plus R2 square is 1 square which is 1, plus R1 into R2 which is 2. So I have 1 by 3 into pi is 22 by 7 into 14, so this is 4 plus 1 plus 2 which is 4 plus 3 is 7. So 7 gets cancelled. So we are actually left with 22 into 14 by 3, which gives us 102.66 centimeter cube. So this is the volume. So this is the volume of water which the glass holds. So this is the first problem. The second problem, which states that the slant height of the frustum of a cone is 4 centimeters and the perimeter, which is the circumference of its circular ends, are 18 centimeters and 16 centimeters. Find the curved surface area of the frustum. So we have a cone here, a frustum of a cone, where the slant height L, so L is the slant height, which is 4 centimeters, and the perimeter has been given. So the perimeter is 18 here and the smaller perimeter is 6. So we know that the formula for the perimeter is 2 pi r. So let the radius be r1 and the smaller radius be r2. So 2 pi r1 equals 18 and 2 pi r2 equals 6. Alright, so now I need to find what is R1 and R2. So R1 definitely is, so 18 by 2 is 9 by pi, and R2 is 6 by 2 is 3 by pi centimeters. So this is also centimeters. So we need to find the curved surface area. So what is the curved surface area? it's given by the expression pi into, so this expression here, R1 is 9 by pi plus 3 by pi into L, which is 4. So I can take the LCM because pi is common, so I have pi into 9 plus 3 is 12 by pi into 4. So what is 12 into 4? It is 48 centimeters square. So this is the curved surface area of the frustum of the cone. So problem 3, a fist, the cap which is used by Turks is in the shape of a frustum of a cone. So you can see the figure there. So there's a cap which looks like a frustum of a cone. If its radius on the open side is 10, so this is the open side because this is a cap which you actually use it on your head, isn't it? So the open side radius is 10 centimeters and the radius of the upper base is 4 and the slant height is 15. So find the area of the material which is used for making it. So we need to find the area. So to find the area, I have to find the curved surface area and also the area of the upper base, because when you have a cap and you actually put it on your head, isn't it? So the bottom portion is open whereas the top portion is closed. So the curved surface area will only give me the area of the frustum of the cone, which is curved, plus I need to add the upper base area. So therefore I have the area, which is nothing but the curved surface area plus the area of the upper base, which is a circle, which is pi r2 square, where r2 is the radius of the smaller circle here. So what is the expression? The expression for the curved surface area is pi into, so r1 is 10, r2 is 4 into L, which is 15, plus pi, r2 is 4, 4 square is 60. So when we calculate, we get the total area is 710.285 centimeters square. So this is the total area, right? So this is the total area which is required to make the cap. A container opened from the top and made up of metal sheet is in the form of a frustum of a cone of height 16 centimeters with radii of its lower and upper ends as 8 and 20 centimeters. So R1 is 20 and R2 is 8 centimeter. Find the cost of milk which can be completely fill the container at the rate of rupees 20 per liter. So we need to find the cost of milk which can completely fill the container where the rate is 20 per liter. Also find the cost of the metal sheet used to make the container if the cost is 8 rupees per 100 centimeters square. So of course we need to take the value of pi as 3.14. So this again is a very simple problem. So here there is a container open from the top. So you have a container. So the container is open from the top and the radius of the lower, so the lower radius is 8 and the upper radius is 20, right? So the upper one is much more larger when compared to the lower one. So now we need to find the total volume. So what is the total volume given by? The volume is given by the expression 1 by 3 into pi into h is of course 16. So this is 16 centimeters which is given in the problem. 16 into r1 square, where r1 is the radius of the larger base, which is 20 square, plus r2 is 8 square, plus r1 into r2, which is 20 into 8. So this is the total volume of the frustum of the cylinder or the container. So the total volume what we get, so if you calculate, you would get 10459.42 centimeter cube. So this is the total volume. So now this container is filled with milk. And what is the rate? The rate is 20 per liter. So what is the volume in liters. So the volume in liters is nothing but this divided by 1000. So I have 10,459.42 divided by 1000. So I get 10.459 liters. Alright. So per liter is 20 rupees. So for 10.45 liters, what is the cost? So I have to multiply this. So the total cost is 20 into 10.459. So which gives me a value of 209. So rupees 209. So when I fill this container with milk, where the cost of a liter of milk is 20 rupees, since it can accommodate 10.45 liters here, so the total cost is going to be rupees 209. And what is the total curved surface area? So now I need to find the total curved surface area. Now in the previous case, the top was closed. So here in the container, the bottom is closed and the bottom is the smaller region. So the total surface area is nothing but the curved surface area plus the area of the bottom, which is pi into r2 square. And what is the curved surface area? The curved surface area is given by pi into r1, which is 20, plus 8 into L plus pi into r2. R2 is 8 square. So here I need to find the value of L. So what is L? L is given by the expression root of h square. What is h? H is 16 square plus r1 minus r2, which is 20 minus 8, which is 12 square. So I have 16 square plus 12 square, you get 400. So root 400 is nothing but 20 centimeters. So the value of L is 20. So I substitute the value of L here as 20. So now if I calculate, I would get the value as 1961.14 centimeter square. Right? So this is the total area required for making this container. So now the question is, the cost of the metal to make this container is 8 per 100. Alright? So therefore the total cost to make this container would be 1961.14 into 8, but it is per 100, so divided by 100. So it's going to be 19.6114 into 8. So what will it give me? It's going to give me approximately rupees 157. Okay, so I need 157 rupees to make this container. Problem 5 is a very interesting problem. It states that a metallic right circular cone, which is 20 centimeters high and whose vertical angle is 60 degrees, is cut into two parts at the middle of its height by a plane parallel to its base. If the frustum, which is so obtained, is drawn in the form of a wire of diameter 1 by 16 centimeters, find the length. We need to find the total length of the wire. So this is a very interesting problem. So what is being given here is there is a metallic right circular cone. So there is a cone and the total height is 20 centimeters. So this is given. And what else is given? The vertical angle is 60 degrees. So this is 60. It is cut into two parts exactly in the middle, which is parallel to the base. So this is the base here. So we are actually going to cut it exactly at the center, parallel to the base. So I make a cut here. So that this is 10 and this is 10 centimeters. So what happens to this portion which is being cut? So this portion is a frustum which has been obtained here. So the frustum which has been obtained is drawn into a wire. So this is drawn into a wire of diameter 1 by 16 centimeters. So how much of length can be drawn is the question. So now I have to find out. The first thing which has to be done is we have to find the radius. So I do not know the radius R1, neither do I know the radius R2. Okay, so now this becomes a right angle triangle. You observe, so I have A, B and C. I have A, B and C, and then it's divided in the center like this, B, D and E. Since I'm actually dividing it to half, this is 30 degrees and AE is 10, EC is also 10 here. Alright, so this is what is given in the problem. So now I need to find DE and I also need to find BC. So we can use tan expression. So if I consider triangle ADE, now what is tan 30? So tan 30 is nothing but opposite side by adjacent side, which is DE by AE. And what is DE? DE is AE, which is 10 into tan 30. So we can easily find the value of DE. So it is 1 by root 3. So tan 30 is 1 by root 3. So DE is 10 by root 3 centimeters. So this becomes R2. Alright, next, what is BC? I get BC if I consider triangle. So we consider triangle ABC. So take tan 30, which is opposite side BC by the adjacent side AC. So what is BC? BC is AC, which is 20 into tan 30, 1 by root 3. And this is R1. So R1 is 20 by root 3 centimeters and R2 is 10 by root 3 centimeters. So now we know the value of R1, we know the value of R2, we know H also. So therefore we can actually find the volume. So can I find the volume? I can find the volume very easily, which is 1 by 3 pi into H, which is 10, into R1 square, which is 20 by root 3 the whole square, plus 10 by root 3 the whole square, plus R1 into R2, which is 200 by 3. So when I do the calculation, I get the volume as equal to 22000 by 9 centimeter cube. Alright, so now this is the volume of the cone and this is drawn into a wire of diameter 1 by 16. So the radius is nothing but 1 by 32. Half of 1 by 16 is 1 by 32. Now what is the volume of wire? Volume of wire is nothing but the length into the area of cross section, which is pi r square. So the length L I need to find into pi into r is 1 by 32 whole square. Now since we are actually drawing the wire from the frustum of the cone itself, these two volumes should be equal. So what do? I equate these two. So therefore 22000 by 9 equals L into pi into 1 by 32 the whole square. So now if I do the calculation and find out L, please do it correctly. So you get L as 79644 centimeters. Okay, so this is the total length of the wire, or if I want it in meters, so you just divide this by 100, so you get L as 7964.44 meters. So this happens to be the total length of the wire. Right? So here in this exercise we have solved problems regarding frustum of a cone. And though they look complicated, it's actually very simple. You just have to remember these expressions. The volume of the frustum of the cone, and then you have the curved surface area as well as total surface area. You remember these expressions, you will be able to find all the values you need and solve the problems very easily. So this is exercise 4 of this chapter. So in the next video segment we will solve the optional exercise, which is exercise 5, which is very interesting, and we also have 2 derivations there. Okay, so we'll do that. So keep a watch on that video, and you also have the link for joining the Telegram group for 10 mathematics, wherein I'll be uploading all the materials for 10 mathematics. So do not forget to join the Telegram group. The link has been given in the description. And to view all the other videos of 10 mathematics, go through the I icon or the playlist for 10th. And I've also arranged the playlist on different chapters, so you can go through all the videos wherein I've solved all the exercise problems and given the required explanation. So do not forget to like, share and subscribe, and press the bell icon to get notifications of further uploads, and thanks for watching.